In this short video, I'm going to show you how to calculate curve number based on the data that you have. This GIS file that I have provided for you has a number of data in it. First of all, I have given you soil hydrogroups, which will be used to calculate curve number for your watershed, which is Lower Minnesota watershed. So first of all, let me expand it. You will see that soil hydrogroups are A, B, C, and D. If I check this, you can see the distribution of soil hydrogroups. Now, the other type of data that I have given you is land use data. So I'm going to check the land use. First of all, let's expand it. Land use will be open water, developed area, all the way to wetlands. The colors are not perfectly selected. I will let you to change the color, and I will show you how to do that too. So when you check land use, you will see that this is a map of land use over here. Different colors mean different land uses. If I right click on this and click on attribute table, you will see that this data that I have has different columns. This grid code is really important for us. Every classification has a grid code. For example, open water has a unique number associated to it called, and then that number is 11. If I go down, other different types of land uses have different number. For example, developed open space has a grid code of 21. This grid code is going to be important later in our calculations. Okay, I'm going to close this. Similarly, for soil group, I didn't show it to you, but you can right click on it and then click on attribute table to see that the hydrogroup for every polygon is listed over here. All right, I'm going to close this as well. So this was the land use, and I'm going to uncheck and minimize it. And the last thing is DEM. This is the digital elevation model of your watershed, and the elevation changes from 100 to 366. Perfect. And this last thing is the boundaries of your watershed, and of course the topographic map that I have the last data for you over here. All right, so the first thing that we need to do is, right now our soil map and land use map, there are different maps, but in order to calculate curve number, we want these two maps to be on top of each other, right? That function in ArcGIS is called union. So when you go under analysis and click on tools, you're going to search for union. Press enter, click on union box. Okay, so it's asking you, what are your input data? I have two inputs. One would be soil hydrogroups, and the other one would be land use data. Okay, I want all attributes to be connected to each other, right? So I'm going to have all attributes selected, and then run the tool. After a couple of seconds, depending on your computer, you'll see a new shapefile is going to show up over here that has combined features from your soil and from your land use. I'm going to pause the video. When the shapefile is over here, I'll resume the video and I'll show how it looks like. As you can see now, I have a new polygon showing up on my map, and if I zoom in, you will see that it is consisted of a lot of polygons into each other. Now, let's right click and click on attribute table on the polygon. So you can see that this attribute table has soil characteristic. It also had the grid code, and grid code shows you how different land uses are incorporated. Remember, 11, for example, was water. So if I click on any of these polygons, it gives me soil hydrogroup. It also gives me the grid code or the land use number as well. Perfect. I'm going to close this. So I am going to add 3 columns to this table, and these columns are going to help us to calculate curve number. So in order to add column, you need to click on add field. I'm going to click on add field, and then over here, when it says field, I'm going to, the first column is going to be called LU, or land use. It is very important to change the data type, so I'm going to click on this long and change it to text. All right, so that was one column. I'm going to add another column, so if I click here, as it says, another column will be added. So this column I'm going to call LU, land use, underscore soil, SOIL, there we go. Again, I'm going to change the type to text. There we go. This cell is a little bit finicky, so I need to multiple click on it to be able to change it. And then add the last column, and I'm going to call in this column area. Now, it is important that change this time, I'm not going to change it to text, I'm going to change it to float, which is a number format. Okay, that's it. These are all the columns that I wanted to add. This last one I don't need to add, so I'm going to uncheck it. So LU underscore soil, and area. Once you're done, it is very important to click on save. Click on save. It will take a couple of seconds, and now if I close this, you will see that there are 3 columns added to my table: LU underscore soil, and area. Okay, now I'm going to populate these columns. LU is going to show the grid code. So if I right click on the header of LU and click on calculate field, I'll be able to populate all of these cells. I want these cells to reflect whatever is written in the grid code. So I want my LU over here. I'm going to click over here. I want my LU to be exactly like grid code cell. I'm going to find grid code. It's over here. First click over here and then double click on grid code. There we go. You will see that the grid code is in between 2 exclamation marks. Once this is done, I'm going to run it, and after a couple of seconds, ArcGIS is going to think, and then all of these cells under LU are going to reflect exactly whatever is written in grid code column as well. This is doing its thing, so I'm going to pause and resume the video when it's done. You can see that now LU reflecting exactly what grid code is. Now, the next column, I want to reflect both grid code or LU underscore the soil hydrogroup C. So for example here, this cell that my cursor is hovering over right now, after my calculations are complete, it should show 0 underscore C. Okay, let's see how we can do that. And again, I'm going to right click on the header of this column, click on calculate field. Now I want to show LU, so I'm going to find LU over here and double click on it. Okay, LU is over here. Again, I am going to have an underscore in between LU and soil. So I'm going to write plus and then put the underscore in between quotation marks like this, and then again plus soil. And soil has been written in hydrogroup CD over here. So I'm going to find that column name over here. It is written over here. I'm going to double click on it and it shows up after that. Now if I click run, I expect to see both land use and soil type all the way down in this column. I'm going to click run. It is going to take a while, so I will pause and resume when it's ready. Great, now I have LU underscore soil hydrogroup. So if I go down, you will see that all different land uses and soil types now they're shown all together. So you know that every polygon, for example, let's see if I click on this, you will see that the land use and soil type is 82 underscore C. Very cool. Now, the last thing that I want to do over here is to calculate area of each single polygon over here. I want to know how much area that covers. So again, to do that, I'm going to right click on the header of that column, area, and then click on calculate geometry. So when you calculate the geometry, you want to specify what you want to get from that. I am going to calculate area. So I'm going to click on area over here, select property and click area, and you need to find a unit for the area. You could go with miles. I'm going to select square kilometers, but it's important to know the area. Later, if you want to present your data, you should be able to know what units you used. All right, and then eventually for the coordinate system, I am going to select the coordinate system to the union map that I have created. There we go. Okay, I'm going to click run. Again, this is a time-consuming process. It's going to take about 1 to 2 minutes. So I'm going to pause the video and then resume when it's ready. Now, as you can see over here, the area is populated and the unit for the area is square kilometer for every polygon. So if I click on this polygon, for example, it shows the area of that polygon in a square kilometer. Now, there's a point though. So let me scroll down a little bit. Sometimes you will see that there are multiple polygons that they have same land use and soil combination. Take a look at these three, for example, 95A, 95A, and 95A. Let's see them on the map. So if I select them over here, they turn blue, and if I zoom out, I should be able to find these on the map. You can see that this little selected area, if I zoom in, and this is just as a sample. So this is one of those polygons that have been selected. And let's see if we can find the other ones. They are actually next to each other. So all the polygons that I have selected are located over here approximately. One is this one, and the other two are over here. Okay. We want ArcGIS to calculate the summation of areas that have the same land use soil type combination. We want to know overall what percentage of the watershed has the same land use soil type combination. So first of all, I'm going to go under Edit and clear my selections. I don't want these cells to be selected, so I'm going to clear my selections. Great. Now, I am going to create a summary table by right-clicking on the area header and then click on Summarize. I want to summarize the area, and the statistic should be sum, based on my land use underscore soil. In other words, I am telling ArcGIS to calculate the area of the polygons that have same land use and soil type combination and give me that total area in a table. The name of the table is over here. I'm going to change the name actually to something more descriptive. I'm going to say summary table underscore table. Perfect. So I'm going to click run and pause the video. When the table pops up, the table pops up right after this, and I'm going to show you how it looks like. All right, as you can see, there is a summary table, and if I right click on it and then click open, the table will open over here. So what do I have here? I have land use and soil type over here in the second column, and I have summary of area. So this is telling me that, for example, 34 square kilometer, about 34 square kilometers of the watershed has the land use of 95 and soil type of B. How do I find what is 95? That's a good question. How do I find what 95 represents? So if you right click on your land use data and go to symbology, you'll see a number is associated with different types. So for example, 95 is related to this land use, which is wetlands, or 90 is represented by woody wetlands. So these are the numbers associated with land use numbers over here. Okay. Before we do the final step and calculate the curve number, we need to fix some of the errors. And the errors are happening because of the union function. You'll see that there are some cells that they have a land use and they don't have a soil, right? And if I go scroll up, you'll see that, for example, over here, 11 underscore nothing. We need to remove these cells. Also, we need to remove something else. So take a look at here. We have it starts from number 11, 21, 22 to 95. We don't have a land use type of 0. This is an artifact of the union function that we did. You can select that row and delete it. So for example, if I select this first row that I want to delete because there is no 0 land use, I did select it by clicking on the left hand side of the cell and then click on delete button over here. It deletes the selected. Now 0A is gone. I'm going to select, you can select multiple of them. I'm going to select the first 3 because they're all 0 and then click delete. It's gone. Okay, so now I'm going to remove the other ones. So the other ones that they don't have soil. So I'm going to click on 11 underscore, and then if you want to select multiple rows, you can hold Control on your keyboard and then select the ones that you want to. I'm going to hold Control, select 21, hold Control, select 22 underscore nothing. Similarly, all land uses, they have something like this, so I'm going to select them one by one. Once they're all selected, now you can click on delete, and they will be deleted from the list over here. Now you have all the correct land uses and soil types on this summary table that you created. All right, the next step is to create a curve number column over here. So again, now you know how you will be able to create a curve number. Before doing that though, we need to change save the changes that we have done over here. So it is important that you are under edit and then click on save. It asks you if you want to save, yes, and after that it will be saved. Okay, so now that the changes that you have done is saved, we want to add some columns over here. So I'm going to click on add and then click and then type CN or curve number. That would be one column that I will be adding, and the type of data that I'm going to input in that is going to be short, and short is short integer. I'm going to add another column and call that CN curve number underscore area, the area of that specific curve number. All right. Once you are done adding these two, and oh, before I forget, you need to change the data type to floats. Perfect. Once you have done this, again, it is important to click on save to save your changes. Now you can close this fields summary table, and you will see that there are two columns added to your table. To calculate curve number for each land use soil type, we need a table to refer to. I have sent you a table, and I'm going to show it to you over here in a Word document. This is a land use soil type table that you can figure out the curve number based on. For example, if your land use is open space, then for open space, different A, B, C, D soil groups, you'll be able to find the value of curve number. Now, let's go back to our ArcGIS table. Scrolling up, my land use is 11 and soil type is A. So look at here, land use is 11, means open water, and soil type is A. I'm going to go to my Word document. Land use was 11 open water, soil type was A, B, C, D. You can see that for all of them, no matter what, it is equal to 100. So I can go back to my table, and over here, click and write 100 and press enter. So this would be the curve number for this land use and soil type combination. So it doesn't matter, because 11 represents open water, and as I showed, it doesn't matter what your soil type is, A, B, or C, or D. When you have open water, all of the curve numbers are going to be 100. So I can go ahead and over here write 100, and then over here write 100 and 100. Perfect. Next is 21. 21 represents developed open space. 21 represent developed open space. So this table is not a complete table based on what you have over there. I'm going to look and see what is the closest one to developed open space. And it looks like that this description is close to developed open space. So I'm going to, for developed open space hydrogroup A, I'm going to put 49, and then for the others would be 69, 79, and 84. So this would be 49 over here for A. For B, it would be 69. For C, it was 79. And for D, it was equal to 84. 84. Perfect. So you're going to do the same thing for all other combinations of land use and soil type and populate your curve number column. I'm going to pause the video and do the same thing and come back and show you the results. All right, so I completed all these cells over here, but there are a couple of things that I want you to pay attention. So land use number 90 and 95, they are wetlands over here, right? And if you take a look at this reference table that I have, there are no wetlands listed over here. So because of that, I went with water, which was the closest one, and I selected 100 for curve number. Also, for some rows, for these two, for example, shrubs, you can see that there is no curve number value for soil type A. I went ahead, and if there was a condition, for example, over here, I used 30 over here as well. So everything here right now, all the curve numbers are completed. Now, what I want to calculate is one curve number for the entire basin. Let me turn off this shapefile. Okay, so I want to have only one curve number for lower Minnesota watershed, right? So right now I have one curve number for the combination of land use and soil type. I want to calculate the composite curve number. So the composite curve number, if you remember, had an equation that was an weighted average. So in the numerator, you have curve number times area, and then in the denominator, you have the summation of all areas, right? Okay. So what I'm going to do is, first of all, go back to ArcGIS, and here, this column curve number underscore area is going to be, as a matter of fact, curve number times area. Okay, so if I right click on it and then click on calculate field, curve number area is going to be equal to curve number, so double click on curve number over here, times would be this represents times area. And what area? Sum of areas over here. So I'm gonna select that, click over here, and then double click on sum of area. So curve number underscore area is going to be curve number times sum of area. I'm going to click run. You will see that right now I have the value of curve number times area, which is the numerator of this fraction. Although I need to take a summation of that, right? Okay, so let's take a summation of that. I want to take a summation of all these cells over here. So in order to do that, I'm going to right click on this and then click on statistics. When you click on statistics, you'll be able to see the summation of that column over here. So I'm going to copy the summation and then go to Excel and paste the summation as one of these cells. You can see that the number is over here. It shows it like this, and if you extend the cell, it will be fixed. Okay, so that's the summation. That's the numerator, or n. Now I'm going to calculate the denominator too. Denominator is the summation of area. So if I go back to ArcGIS, I don't need this anymore, so I'm going to close it. Area was this column, right? So I'm going to right click on it and then click on statistics and figure out the summation of areas. This is the summation of all areas over here. I'm going to copy that, go back to Excel, and paste it under denominator. Okay, so now the composite curve number is going to be numerator divided by denominator. All right, there we go. So you can see I can say that this is equal to 79 approximately. So for your lower Minnesota watershed, the curve number is going to be equal to 79. This is the number, this 79 would be the number that you use as one variable in your HEC HMS hydrologic modeling. All right, so now you know how to calculate curve number. The other thing that you need for HEC HMS modeling is slope and length of the river, right? So as you can see over here, I have given you the DEM, and you already know, based on the assignment that you have done, how to calculate the average slope based on a digital elevation model, and how to calculate length of the river. So once you have slope, length of the river, and curve number, and also the precipitation from NOAA's website, you will be able to go ahead and input all those variables in HEC HMS and do the hydrologic modeling.